Hello, welcome to Physics Explained, where we crack the code of nature. So let's dive into today's problem. Uh, Here, this is a cube consisting of batteries, resistors, and capacitors. So it is given four batteries of EMF E1 equal to 4 volt, E2 equal to 8 volt, E3 equals 12 volt, and E4 equal to 16 volt. Four capacitors with same capacitance C1 equals C2 equals C3 equals C4 equal to 1 mF and four equivalent resistors. The value is not given. Let it is R. The internal resistance of the battery is negligible. Calculate the total energy W accumulated on the capacitors when a steady state of the system is established. The points H, B, and H, here B are short connected. Find the charge on the capacitor C2 in the new steady state. So let's first draw the cubic system in 2D. Let's see how I draw. Okay, I am taking this A, B, C, D of a face. Okay, you can take anything. So here is A, there is a resistor B, then there is a battery. Resistor is R. Okay, battery E2. E2 is 8 volt between B and C. Then C and D is the capacitor. C1 is B. C1 is equal to 1 mF. Then AD is a battery of E1. E1 is 4 volts. Okay. Now the upper face is done. Now what is connected to BC? Here is B, here is C. So BC is connected with G and F. So B and F is connected by a resistor R. This is F. F and G is connected by a battery E4. E4 is 16 volts. Then G. In between C and G there is a capacitor of C2. C2 1 mF. Then what is connected with F and G? F and G is connected with H and E, right? So between F and E there is a capacitor C4. This is C4 1 mF. Between F and E. Then between E and H there is a battery of E3 EMF. E3 is 12 volt. This is the point H. Between G and H there is a resistor of R. A resistor of R. Now A is connected with E, D is connected with H. So A is connected with E. There is a capacitor between A and E. This is C3, which is also 1 mF. Between D and H there is a resistor. Or this is the circuit diagram in 2D. So our main aim is first part, total energy accumulated on capacitors when there is steady state. Our second aim is B and H are sorted. Find charge on capacitor. charge on capacitor C2. So first part is to find total energy accumulated on the capacitor when steady state of the system is established. So when the steady state will be established, the capacitors will be fully charged. So they can't conduct electricity because they are fully charged. So they behave like an open wire, open circuit. So let's draw circuit diagram when there is steady state. Okay. So I'm copying this. Cut. Uh, Move right. Control V. Copy it here. So go to the left side. Paste. Okay, this is the circuit. Let's make the capacitors open. Okay, then capacitor. What is C4? Right? C2 is C1. So our circuit becomes like this. So mm, there is a battery here. 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 Our connection is something like this. Because other corners, this is open, right? So there will be no flow. The red one is our circuit. A to B, B to F, F to G, G to H, H to D. A, B, F, G, H, A, B, F, G, H, D. This is our circuit loop. So let's find the current because we have to find the energy stored. For energy, we know the capacitor, so half CV square. We first find the current, then by the current we can find the potential drop across the capacitors. Then we can find the energy, then add all of the capacitors energy to find total energy, right? So let's find first current. So this is the circuit. This is A point. This is D. Here is 4 volt. Then this is B. This is F. RR between F and G. There is a battery of 16 volt. Here is G. Then between G and H there is a resistor R. Between H and D there is a resistor R. So all resistors are in series. So R equivalent in the circuit is 4R. Voltage, the 4 volt is opposing the 16 volt. So the net voltage V net is basically 16 minus 4 equal to 12 volts. Current I equal to V by R according to Ohm's law. So 12 divided by 4R is 3 by R. This is the net current. So now let's find the potential drops across each capacitor. So I will first take the loop A, D, B, C, D, A, B, C, right? D, A, B, C. So I was visible. So this is the loop. This is A, this is 4 volt, this is D, this is resistor R, this is B, this is the 8 volt battery, this point is C, this point is C. Here is the capacitor C1. So I am now writing KVL. So let the voltage drop across C1 is VC1. VC1. I am writing this as this B A B C loop. When I move from D to A, there is a voltage drop of 4 volts. So VC1 minus 4. The current is moving like this. So there is also voltage drop from A to B. So minus for voltage drop and plus for voltage increase. Minus IR. Here is the current I. So I is basically 3 by R. So 3 by R into resistor R. When I move from B to C, there is a voltage increase of 8 volt. So plus 8 equals 0. RR cancel. VC1 minus 7 plus 8 equals 0. VC1 equal to minus 1. This is the voltage drop across C1. Now let's find across C2. For C2 voltage drop, I am taking the loop C, B, F, G. This is C. There is a 8 volt battery between B. Then F. Between B and F, there is a resistor R. Between F and G is a battery of 16 volt. This is G. Here is the capacitor C2. And writing for loop C, A, C, B, F, G. Here is the current flowing I. So let the voltage drop between C and G voltage difference or the voltage drop across the capacitor C2 is VC2. So as I move from C to B, there is a voltage drop of 8 volt. So VC2 minus 8. When I move from B to F, the current is flowing B to F. So there is a voltage drop of IR minus 3 by R into R. When I move from F to G, there is a voltage increase of 16 volt. F to G, there is a voltage increase of 16 volt. So plus 16 equals 0. So VC2 minus 11 plus 16 equals 0. Vc2 is basically -5. This is the voltage drop across the capacitor C2. Let's find the voltage drop across the capacitor C4. So I'm taking the loop FGHE. FGHE. Here, this is F. Then I find G. There is a battery of 16 volt. This is G, C, and H. There is a resistor of R. Between E and H, I think there is a battery of 12 volt. Okay, of 12 volts. And there is a capacitor C4 is connected. So let the voltage drop be Vc4. So I'm taking the loop like this. FGHE. FGHE loop. So let the voltage drop be Vc4. Vc4 and as I move from F to G, there is a voltage increase of 16 volt plus 16. As I move from G to H, there is a voltage drop as the current is moving from G to H. So there is a voltage drop of IR. So minus 3 by R into R. As I move from H to E, there is a voltage of 12 volt. As the battery is opposite, minus 12 equals 0. So Vc4 plus 16 minus 3 minus 12 equals 0. Vc4 is basically minus 1. Now we have to find the voltage drop across this. For this I am taking a loop ABFE. 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 Right? So this is A, there is a resistor E, between B and F, there is a resistor F. Here is a I am VC4, I am writing this. This is E point. We have to find the voltage difference between these two points, right? So how we are going to find? Similar start. Here it is flowing current I, here it is flowing current I. This voltage drop from E to F because we are in the previous loop, FGH, first F to G, then G to H, then H to E, then E to F. When we go from E to F, there is a voltage drop of minus 1. We are now will move from F to E. So this voltage will be negative or minus 1. This is plus 1. So let's VA minus I into R. This is equal to 3. Then again minus 3 from B to F. Then F to E. This is plus 1. Is basically VE. So the voltage difference between VAE, which is also the voltage drop across the capacitor VC3, because the capacitor is connected like this, C3, is basically minus 6 plus 1, this is plus 5. We have now, we have 4 capacitors. We now calculated 4 potential drops between across the capacitors. We'll write down the individual energy stored in the capacitors, then add them to get the final total energy. So if the capacitors one are same, I can write the total energy half C V1 square plus V2 square plus V3 square plus V4 square, right? Half C is basically 1 millifarad. V1, VC1, sorry, VC1 square, VC1 square, VC2 square, VC3 square, VC4 square. So VC1 got minus 1, so minus 1 square is 1 plus V2. VT square is basically minus 5 square 25 plus VC3. VC3 square, VC3 is 5, so this will be 25 plus VC4. VC4 is minus 1 square is 1. So uh, 25 plus 25, 50, 52 divided by 2. 26 microjoule, the total energy. Now they said that if we connected B and H, right? It said B and H. This is B point and this is H point. So what is the potential? So what is the charge in capacitor C2? Capacitor C2 is here, right? So C in the steady state. Okay. When will the steady state be? When the capacitors will be charged. Okay. So this will be charged. Then this will be charged. All the capacitors will be charged. So how the current will flow? The current will flow like this: A to B. Then it is not going to flow from B to F, F to G, and G to H because we have short circuited the B to H part. So in this part there is no resistors. So the current will follow this path. Then H2, here is this C1 is connected with D, and there is a current flow across this tree. So there is a potential drop across C1. So there will be some charges. Then see the C4. C4 is connected with, we can find also for C4. But in this case we have to find across C2, right? Then we can find for C3 because A is connected with C3 and current is flowing through A terminal, so there will be potential drop across C3, so there will be a non-zero charge. But C2 is connected with C between C and G, and there is no current flow through this branch, either in terminal C or either in terminal G. So, as there is no current, there will be no potential drop across this. That's why the voltage drop is zero. So, as charge equal to C into V, charge in C2 will be zero at steady state in this new circuit. This is the first method by which we can argue. We have also second method. Let's calculate the potential drop across C2 as it comes zero or not. So let's calculate. Okay, I'm taking this loop. To calculate with C and V, right? So let's first find current I. The new circuit. New circuit is basically the C. This is the 4 volt. This is supporting, V to H it is short circuited, so there will be no rows of these batteries. So 4 volt divided by this resistor R, this resistor R. This is basically V to H, right? So W to H. Hmm. Okay, no problem. Current flows is basically E1 divided by 2R. E1 is given as 4 volt. Yes, 4 volt. So this is 2 by R. This is a circuit. A, it is D, this resistor R. This is H. This is a resistor 10 and VR, and B and H are connected like this. Now, what will the voltage it be? Let this point is 4 volt. This point is 0. This point is V. This point is 0 as A to D. There will be an increase in 4 volt. So the voltage at D will be 4. Current will flow like this. So here at H point, the voltage VH is basically there is a voltage drop. So 4 minus I into R. 2 is 2 volt. This will be 2 volt. So B is connected with B will be also 2 volt. Right? Now see in this part we get the this is basically 2 volt. In let's take the loop. This is B. This is I think I forgot. This is a V is 2 volt. There is a capacitor between F. This is G. This is sorry, this voltage G. This battery is of 16 volt. And between B and C, the battery is 8 volt. Okay, 8 volts. This point is C, right? So C. Suppose okay, this is 2 volt at VB. So what will be at VC? VC will be 10 volt. As we go from B to C, there is an increase in 10 volts, right? So as there is no I hope I get correctly right. 10 minus 2 is 8 volt. Okay. Correct. Then there is an F point. This is H. Okay. The G is connected. Wait. The G is connected with H, right? G is connected with H. Okay. 2 R. So I have to find VF and VG. Right? So how can you find? Let the current be I in the circuit, right? So I will be writing KVL for BFGH. So VB minus SB to F increase decreasing potential. So I into R F to G increasing potential plus 16 volt G to H decreasing potential minus IR equal to VH. VH get cancels. So I comes as 2IR equals 16 by 2R, basically 8 by R. So here this current was 8 by R. So what is the potential drop? It's given 8 volt. To BV is 2 volt. VF will be what? 2 minus 8 is equal minus 6 volt. What is the BG? BG is VF plus 60. This is basically 10 volt. You see, VC is 10 volt. VG is also 10 volt. This is the capacitor C2. This side is 10 volt. This side is 10 volt. The voltage difference is 0. That's why the current in the steady state across C2 when B and H are connected, short circuited, it will be 0. So I hope you understood this solution. If you have any question, write it down in the comment section. Let's meet in the next video.